Okay, so welcome back. Happy Friday, happy Halloween. Today we are going to talk about factoring trinomials. It's a brand new topic, and it is the other direction of the problems that we ended last class with. So we'll start there today. Next class we have a little bit more about factoring, and then the class after that, Wednesday, is our upcoming quest. Fiona.
But you did say that today's class next week.
That's right. The quest is on classes 19 to 23, and today is class number 24. So nothing we do today is covered on the quest. So you've already seen all the material for the quest. And again, there are practice problems for the quest in the packet. Notice that we do not have scheduled in here a review day right before the quest. So you got to find some time outside of class to work on those practice problems. And again, use the YouTube videos and the solutions, which are up on Moodle. Other questions about the schedule? So Wednesday coming up is our quest. Okay. All right. So that's coming up there. And let's start again here on page 27. We'll go to the daily summary at the top. Iman. Okay, so this is going to be a new idea that we will discuss momentarily. Number one is a problem that we essentially did last class. It says multiply these things out. So we're going to do this quickly and then just make a quick observation. I'll do the lobster claw idea. Remember, everything in the first set of parentheses multiplies by everything in the second set of parentheses. X times x is x squared. X times 7 is a plus 7x. 2 times x is a plus 2x, and then 2 times 7 is a plus 14. And then we'll just combine those two terms in the middle to get our final answer, x squared plus 9x plus 14. So we did that much quicker today than we did last time, but it's old, and you did homework on this last night. And so just a quick observation here that if we multiply these two numbers, let me circle the signs as well. If we multiply these two numbers right here, you guys agree that's exactly where the 14 came from? So the 14 was the product of those two numbers. And then where did this 9 come from in terms of those same two numbers? It's the addition, right? It's the sum of those two numbers. And that is also not a coincidence that if you add the plus 7 and the plus 2, then we get our sum of 9. And the x squared in the front is just always going to be there if it's x times x. So it's really just a question of where does the rest of it come from, and we can build the rest of it just by looking at those two numbers, like instantaneously. Multiply the numbers, it goes at the end. Add the numbers, it goes in the middle. Super. So the goal is to go the other direction now. So we're going to look at number 3, which talks about factoring. So the word factor just means take, well, actually the word factor is something you already know. Can you guys tell me the factors of 21? 3 and 7. So to factor something means to turn it into multiplication. That's what we did with the 21, right? We turned it into something times something. So if we want to factor x squared plus 9x plus 14, we are trying to turn it into multiplication. It is currently an addition problem. We want to make it multiplication. Now, we actually have the answer for this one sitting right in front of us because we saw x squared plus 9x plus 14 came from x plus 2 times x plus 7, and that is a multiplication. So the goal today is to take stuff that looks like x squared plus 9x plus 14 and turn it into multiplication, x plus 2 times x plus 7 in this case. So suppose that we didn't have the answer staring at us right at the top of this page, and we just had this problem from scratch. We're looking at x squared plus 9x plus 14. And we know from our observations above and from last class that this guy right here, that positive 14, is supposed to be the product of two numbers. The good news is there aren't that many numbers that multiply together to give me positive 14. Iman? Let's start guessing. 7 and 2 is one possibility. What's another possibility? Two numbers that multiply to 14. 14 and 1. That's it. Yeah, those are the only ways to multiply two numbers and get 14. It's 14 and 1 and 7 and 2. And then we keep reading. We say, okay, but we wanted the one where the two numbers had the sum of 9 because we read this guy and we said, oh, that's supposed to be the sum of the two numbers. So 7 and 2 have the correct sum. It adds up to 9, but 14 and 1 isn't right. It adds up to 15. So we know that our answer, therefore, is this thing. And so that would be our way of factoring the original problem. Okay, so that one we already knew the answer going in. Here's one that we don't know the answer already. Number 4, if we want to factor x squared plus 13x plus 12, and again, that factor word means turn it into the product of two things in parentheses. We're looking to find two numbers whose product is what? Looking at the original, is 12. And so I'm going to try to get us to start getting in the habit of writing the word product above the last number, the 12, and sum above that middle number, the 13. So we seek product. Product is supposed to be 12. And now some of you might already see the correct answer right away, but if we don't, it's totally okay. All we do is we start with the end here, look for numbers whose product is 12. Don't even worry about the sum yet. Just give me two numbers that multiply to 12. So 12 and 1 works, 6 and 2, 4 and 3. Those are the ways we can multiply to 12. There's just not that many. And once we've got the entire list in front of us, then we can think about this idea of the sum. The sum is supposed to be 13. What's the sum of the first two numbers? 13, that's our winner. What's the sum of the next two? 8, that isn't it. And the sum of those two is 7. And so we list all the product ones, and then we find the guy that works. In this case, the sum is supposed to be 13. So this was our answer. And to say that that was our answer means that the two things I just circled in black are exactly equal to each other. They're the same. It's just two different ways to write exactly the same thing. Okay, why do we care about factoring? Well, it's going to take us a few classes before we answer that question. So for right now, I'm going to ask you to bear with me and just do this mathematical thing, and then soon enough we'll have applications where factoring is an appropriate thing to do. Okay, let's look at this next guy. X squared, wait a second, we do that? Oh yeah, all right, so this x squared plus 13x plus 12 is the one we just did. We were looking for two numbers whose product was the positive 12 and whose sum was the positive 13. In the next example, it's one that we saw already today. To factor x squared plus 9x plus 14, we wanted two numbers whose product was which one? Was the 14, and whose sum was positive 9. And so now can you fill in the blank? Don't say it out loud. Make sure everybody has a chance to fill this in. This is the last one right above 6. To factor x squared plus 12x plus 20, fill in those two blanks. Two numbers whose product is something and whose sum is something else. So everybody write those in. What's the product supposed to be? 20. And I'm gonna put a positive in there because so far everything's been pluses, but just get in the habit of copying down that sign. And two numbers whose sum is 12. And again, I'm gonna copy the sign of the 12. It's a positive. Okay, and we always start with the product. We're looking for numbers whose product is 20, and don't even get lost in the sum idea yet. Just think about product of 20. So for example, and I'm going to do this in a really orderly fashion. I can multiply 1 and 20. That would be one way whose product is 20, right? I could do 2 with 10. Does 3 go into 20? No. Does 4 go into 20? Yeah, and so you guys see the order in which I'm doing this? I just start with 1, 2, 3 didn't work, 4 works. Does 5 go into 20? Yes, 5 times 4. But 5 and 4 is exactly the same as 4 and 5, so we're done, right? And you stop as soon as you get one of these things duplicated. So we've got our entire list up here of the factors of 20. We were looking for product of 20 and sum of, in this case, 12. Again, I'll try to follow my own advice by including the sign. Everything was positive so far. And so we can just add all the numbers up that we've listed here. 1 plus 20 is 21. That's not it. 2 plus 10 is 12. That's our winner. 4 plus 5 is 9. That didn't work. And so that means we're ready to write our answer here. It says factor x squared plus 12x plus 20. That's the one we just talked about. So I'm going to start with my empty shell of two parentheses right next to each other. the first terms in each of these have to give me this x squared. What is it going to be? X and x. So there's really nothing to think about. It's just basically part of every answer today. And then all we do is we copy the numbers that we wrote in here, 2 and 10, except I didn't follow my advice. It was positive 2 and positive 10 were the numbers, right? And copying those signs into our blank parentheses here will give us our answer. Okay, so we've got our answer. It's factored, it's done, and we're happy with that one. I was going to say something here. So again, the two things we were looking for in this problem were a product of 20 and a sum of 12. And I just want to highlight that we have been focused entirely on the product thing first. That is your first priority, is to make that product. Because if you focus on the sum, you want to find things whose sum is 12. Well, there's a lot longer list of numbers than the 3 pairs of numbers we came up over here. Those are the 3 ways we can multiply 2 numbers and get 20. But if I just want 2 numbers whose sum is 12, can we start listing them? Give me 2 numbers whose sum is 12. 11 and 1, yep. 6 and 6. 9, 3. 8 and 4. 7 and 5. This is a pretty long list, right? How about 15 and negative 3? How long is this list? Infinite. How long is that list? 3. Pick that one, right? So it's important that we focus on the product. There's 2 things we got to think about, a product and a sum. But focus on the product first. Let that be the driving force. Because listing all the things whose product is a number is a pretty small list. But listing all the numbers that add up to something, it's infinite. Okay, so 8 says, to help you remember this product and sum stuff, think of writing a PS at the bottom of a letter, although I don't know how often you guys write letters anymore, but a PS at the bottom of the letter, except you got to make sure you write it right to left as opposed to the normal way we read and write. So you put a P above the last number and an S above the middle guy, product and sum, okay? Focusing on the product first. Next page. So we're going to try factoring these guys together. So the first one, x squared minus 5x plus 4. We fill in the blanks at the top of the table. We want 2 numbers whose product is positive 4. Make sure you get used to writing those signs in. And 2 numbers whose sum is negative 5. This is the first time we've had a negative up here. But the idea is the same. And again, start with the product. Give me 2 numbers that multiply to 4. Don't even worry about the sum. 2 and 2 is good. I'm going to make them positive 2 and positive 2. Any other numbers that multiply to positive 4? 1 and 4. Yeah, and if we stop here and just decide to start adding them up, we're going to see that we don't get an answer that works. Plus 2 added together is a positive 4. Plus 1 plus 4 is a positive 5, and neither of them gave us the sum we wanted. Jasper? 5 and negative 1, do they multiply? Yeah, we got, I don't think we can say 5 in this one because we got to get 2 numbers who multiply to 4. That's the first priority. And so there's actually some other possibilities that we didn't consider on the first page, is that you could multiply negative 2 by negative 2 and that still gives you the positive 4. So now coming into play is the fact that if you're going to get a positive product, you could have 2 positives to start, but you could also have 2 negatives to start. And if we add negative 2 and negative 2, we get negative 4. That's not it. If we add negative 1 and negative 4, we get negative 5. That's the winner. And once we've found the winner, make sure you actually write the final answer. You're not done just because you found the thing in the table. You always have to end with the double parentheses filled in. So the first terms, x and x. And then the winner in this table is that negative 1 and negative 4. So we just throw them right in here. X minus 1, x minus 4 is the answer. Okay, next problem. x squared plus 2x minus 8. Product is supposed to be negative 8. Sum is supposed to be positive 2. Write those signs in. And then we just start listing numbers. His product is negative 8. Which numbers give me? So we could do 4 and negative 2. What else could we do? Negative 2 and 4. Is that the same or different? Is it the same or different? Those are the same sets of numbers. So we don't need both, right? But what about negative 4 and positive 2? That's different. Okay, so we do need both of those. Okay, any other numbers that give me negative 8? Negative 8? Negative 1 and positive 8 is good. Negative 8 and positive 1, I'll write it in this order. Good. That's it. Those are the ways to multiply and get negative 8. So if something's going to work, it's going to be in this list. And then we just add them up, right? Negative 4 plus 2 is negative 2. Positive 4 plus negative 2 is positive 2. I think that's our winner. And the fact is, I mean, you can just stop as soon as you find the winner. You don't need to continue. I'll continue just because where you put the winner in the table might have been different, but just add them up and find the one that works. And then make sure you know how to go from the winner to the parentheses. Iman.
Does it matter which? It doesn't matter which.
Good question. Yeah, that's exactly right, but it's a good observation. So in the way that I wrote it, it was x plus 4 and x minus 2, but just as well, you could have done x minus 2 and x plus 4. Same thing, both right. Okay, next one up here, x squared minus x minus 12. We fill in the blanks. The product is supposed to be negative 12. Sum is supposed to be negative 1. You got to make sure you pull out that implied 1. We need a number. Okay, so again, try to ignore that sum business. Just start listing numbers that multiply to get negative 12. And for me, it's always an organized way that I do it. First, I try 1. Then I try 2, and I try 3, right? And then 4. And so if you list them in an orderly way, you'll never miss anything, right? There's no way to miss something. So I count 6 different possibilities. Yeah, and so you just add up all the sums until you find the winner. Minus 1 is the right sum, so that's our winner. So make sure you again know how to write down the answer in the parentheses. So x plus 3x minus 4 or other way. Questions on those? Okay, number 10 says that not every trinomial is factorable. So trinomial means how many terms? 3. So we've seen everything we've done has been 3 terms, x squared minus x minus 12. Not every trinomial is factorable. In fact, most are not factorable. So the ones that I've given you here today were specifically chosen because we could factor them. But I don't want you to go away with the impression that everything is factorable. You'll know that you've got a non-factorable one if you try all the possibilities in the product sum table, but none of them works. So let's see one of those. X squared plus 4x plus 12. Here the product is supposed to be positive 12. Make sure you include those signs. And the sum is supposed to be positive 4. And so we just start listing. 4 and 3 is one way, plus 4 plus 3. 12 and 1. 6 and 2. That it? I think that's it. So we add them up. 4 and 3 is a positive 7. 13. 8. Where's the winner? Nowhere. So it just doesn't work. So what do we put in that case? Let's see. So what if I first started off today by asking you to factor 21, and you said, oh, it's 7 times 3, right? So what if I asked you to factor 19? It's prime. I mean, you can't factor it, right? The only way to multiply things to get 19 is 19 and 1, which is kind of trivial. So we call it prime. So what do you think we call this thing right here? We call it prime. It's the same word, same idea. That's our conclusion. Okay, so it's not factorable or it's prime, either way. Okay, finally some observations, and then you guys are going to practice this in the activities. Okay, so first thing, this is our very generic looking trinomial. For example, if I'm trying to compare x squared plus 4x plus 12 to this generic thing where a, b, and c are just numbers, but they're general numbers at the moment, how much is the a to make it match up with this guy up here? A is 1, right? So we could imagine a is 1. And how much is the b to match up? B is 4. And then the c is the 12. So this ax squared plus bx plus c, we're going to be seeing a lot of, and it's just our general way to write down any old one of these trinomials. Okay, so observation A here, it says if a is equal to 1, which it was in this example, and it was in every example today, right? Every one of the problems we did today started x squared, as opposed to problems that start 3x squared. Right? We didn't see anything that started with a 3x squared. Every one of them started with x squared. Next class, we'll see the ones that start with 3. But as long as they all start with 1, then we're looking for two numbers whose product is c, that's the last guy, and whose sum is b, that's the middle guy. That's what we did all of today. And so PS was my little way of remembering product sum. Okay, some other observations. If c is positive, meaning we're trying to multiply two numbers and get something positive, what's the only way to multiply two numbers and get a positive? There are two ways, actually. If they're both positive, right, multiply two positives and it's still positive, or they're both negative. And so that's what it says in B. If c is positive, then the two numbers we seek are both the same sign. And what sign are they? Well, they're the sign of the middle guy. We can just look at a quick example up here at the top. Our winner in this first part A here was this guy right here, right? That was our winner. And we were looking for two numbers with the same sign because of that positive. The only way to get a positive for is two negatives or two positives. And in this case, the answer was two negatives. How come? Because of that sign. We were trying to add numbers and get -5. Well, they had better both be negative in that case. Okay, part C, if C is negative, what's the only way to multiply two numbers and get a negative? One positive, one negative, and that's what it says. Two numbers that seek opposite signs. And if A is not 1, good luck. Like I said, we're going to see these guys next class. They're much harder. Okay, the activity is there. Raise a flag if I can help.